Welcome back to the second installment of the Basics of Physics. And in this, I want to talk about measurements. What is a measurement? Well, measurement is a direct comparison with a known standard and we want to know how good our measurements are. That turns out to be pretty important. When you're doing an experiment and it says you got it wrong, well, how wrong? Or how right, for that matter? How close was your measurement to what you predicted? And how much room for error do you have? Well, it comes down to a very basic idea. What is 1 plus 1? Now, you might be tempted to jump and say, well, it's 2. But we can't say that anymore. We have to be big kids with our numbers now. We have to understand our errors and know the limits of our knowledge. Let me try to explain what I mean here. Here's a pen. Here's my thumb. How long is that? How long is that in inches? I'm going to say an inch, right? There's another one. All right, so 2 inches. That's easy. Well, when I said it was an inch, I hadn't measured it. I was taking a guess. When I hold it up and I measure it carefully, I find out it's a little more than 1 1/4 inches. So if I put 2 of them together, clearly I don't have 2 inches. I'm guessing that it's an inch. But when I say it's an inch, that means it's somewhere between 0.5 to 1.5 inches. That's what 1 inch means. I'm being no more precise than saying it's about an inch. And if I do that twice, well, 0.5 and 0.5 is 1. 1.5 and 1.5 is 3. So 1 plus 1 is somewhere between 1 and 3. And sure enough, look at what I have here. My 1 inch long screws here that I only guessed. Well, when I add them together, I come out to about, it's looking probably about 2.6 inches. And that's what 1 plus 1 can do for you. You need to know what you know. It's certainly fine if you say this is about an inch. It is. It's about an inch. But it's absolutely unacceptable to look at that and say that is exactly an inch. How would you know that? When you compare it to a known standard. All right, let's dispense with inches, because these awkward ways of doing it, the 1/4 inch, the 1/8 of an inch, the 1/16 of an inch, less precise than our metric system here. So let's compare it to the metric system. And here we see it is 3.3 centimeters. So 3.3 centimeters. Now if I put 2 of them together, that should equal 6.6 centimeters. Let's try it. I do the best I can. Oh dear. And I come out with it's 6.7 centimeters. How can that be? Well, clearly, when I said 3.3, I'm still estimating. I'm looking at the line. I'm getting it as close as I can. Can I do better? I don't think I can do better with this situation. Do I have devices that would measure it much, much more accurately? Well, yes, I do. Are they more expensive than this? I think they are. And the more precisely I would like to know something, the more expensive the device is I'll need. But the more I need to know that even that device, is it going to give me a perfect number? Well, what would a perfect number look like for the length of this? Would that be 3.35 0, 0, 0, is where are these zeros coming from? What device is so extremely precise that I can measure it like that? How much would it cost for each additional zero? Eventually, I'm using the best measuring tools we have in a lab anywhere on the planet. That's going to be very, very expensive. And still, it might only get me a couple extra zeros. Do the zeros keep going on? How would we know? Well, in physics, we need to know where our knowledge stops. This is the best I could do with this setup. Because it comes to 6.7 when I have two of them, I'm pretty sure that they're about 3.35. But please understand, this number is getting a little uncertain. So that makes, if I were to try to say this number, that would make this number ridiculous. This you should be laughed at. If you write that number down, you're suggesting a precision you have no right to suggest. So it doesn't matter so much what level of precision we have. What matters is that we know what level of precision we have. We must know the limits of our knowledge. In every experiment, we're going to be using measurements. We're going to be using units, comparison to known standards. We have to know how good a job we're doing comparing things to known standards. And sometimes in physics, you'll get one number, and the teacher will have a different number. And you might say, oh goodness, I don't have the right number. And the teacher will laugh and say, no, that's absolutely correct. You just rounded slightly different. You took a little better knowledge of your number. But because we never have complete precision, it depends on where we're calling that precision. And we should all be on the same page. And as we get better mathematically, we really do end up on the same page. But we have to be aware that no longer do we live in a world where 1 plus 1 equals 2. Our world now centers on 1 plus 1 is somewhere between 1 and 3. There's a cute t-shirt I have that says 2 plus 2 equals 5 for very large values of 2. Now, in the physics world, that is absolutely correct. 2.4, you'd still round to 2. So 2.4 and 2.4, well, it's 4.8. And 4.8, you'd round to 5. So it is reasonable to come up with a solution that 2 plus 2 equals 5 for very large values of 2. And we're really not kidding. So that's our new world of measurements, and that's how we work, the science that we work. It's a new world.